everybody! Welcome to our chemistry class. My name is Beisembayeva. I'm a chemistry teacher. Today we are going to explore the concepts of entropy, enthalpy and Gibbs free energy to understand the main concept of chemistry, which is called spontaneity of chemical reactions. Welcome to our class and let's explore these concepts together.
Good afternoon. Today we are going to explore the concept of entropy and the spontaneity of chemical reactions. And today we are going to focus on Gibbs free energy. Chemists usually work in order to deepen their understanding of how different conditions can affect the rate of chemical reactions and chemical reactions in general. Therefore, chemists will learn deeper different conditions and then they can modify and change the conditions in order to achieve the desired results. Science of thermodynamics is very important for chemistry. The concepts like heat, temperature, enthalpy are the concepts that deepen our understanding about thermodynamics. The first and second law of thermodynamics are very important in chemistry, even in application of chemistry in our life. The first law of thermodynamics concerns with energy, and it is called the law of conservation of energy. The second law of thermodynamics focuses on entropy and spontaneity of chemical reactions. What does the word spontaneous mean? Spontaneous reaction is the reaction that will take place without any input from the outside. If I give some examples of spontaneous processes, the most beautiful example is the reaction of sodium with oxygen. If I take a piece of sodium and leave it in air, oxygen and sodium will spontaneously react with each other. The reaction is very fast, but there is no input from external conditions to make this reaction to happen. Another example of chemical reaction which is spontaneous is the reaction of methane with oxygen. If I mix methane with oxygen in an isolated container, methane will react with oxygen and will produce carbon dioxide and water. This reaction is also spontaneous but very slow. In order to deduce spontaneity of the chemical reactions, we need to refer to the concept of entropy. Entropy is a very important concept in thermodynamics. Entropy explains why mountains crumble, glass shatters, buildings collapse. If we look at this mountain, you can see that here this mountain has low entropy value, because there are a few ways of rearranging it. But if the wind will blow, wind will disintegrate the snow particles and snow will change its shape, but will not change its structure. Therefore, if wind will blow, the entropy of this mountain will increase. The entropy will be high because wind will rearrange the particles. If I create another mountain, I will create the order in the universe. Therefore, I will create lowering of entropy. Now I'm going to create the order in the universe. If I take the beaker and put inside the snow and invert the beaker, I will create a small castle from the snow. And therefore, I will create a low entropy value and highly ordered structure. Let's do it. Nature tends to disorder. It is simplified version of second law of thermodynamics. The wind starts to blow stronger. It's cold outside. Let's go to the warm classroom and I will continue to explore the concept of entropy.
After such a cold weather, I decided to drink a cup of coffee. If I leave this cup of coffee on the table, the heat will flow from hot coffee to my hands or to a table. It means that heat is more dispersed and disordered, and energy will go from hot to cold and no other way around. It means that the system around this cup of coffee will tend to go from low entropy value spontaneously to high entropy value. After exploring the concept of entropy, we are going to move to the next concept, which is called Gibbs free energy. During this lesson, we are going to focus on the next learning objectives. First, we will predict whether a change will result in an increase or decrease in entropy by considering the states of the reactants and products. Also, we are going to calculate entropy changes from a given standard entropy values. We will apply the relationship between Gibbs free energy, enthalpy, and entropy to predict spontaneity of the reactions. We will look at the relationship between delta G and position of equilibrium. We will predict whether the reaction is spontaneous or not using cell values, and determine the standard free energy changes using standard electrode potentials. What is spontaneous process? Spontaneous process is the process that does occur under a specific set of conditions. Non-spontaneous, as opposed to spontaneous, doesn't occur under a specific set of conditions. So we are going to focus on entropy. Entropy refers to distribution of available energy among the particles in a system. Entropy is a measure of the disorder of a system. It is a simplified version of entropy. Symbol of entropy is S, units, joule, Kelvin -1, mole -1. How to determine whether entropy of the reaction increases or decreases? An increase on entropy can result from mixing different types of particles. For example, if we mix particles of salt and particles of water. A change in state where the distance between the particles increases. For example, if we change state from liquid into gas. The increased movement of particles if we boil something. Increasing the number of particles if the state changes from solid into liquid or from liquid into vapor. For example, if we compare entropy change of the system which is at solid state and which is at liquid state, liquid will have higher entropy value. If we compare liquid and vapor, vapor will have higher entropy value. If we compare entropy changes of pure substances and mixture of water and this pure substance, aqueous solution of substance will have higher entropy value. How to determine whether the entropy of the system will increase or decrease based on the chemical reaction and state symbols. If we look at the first chemical equation, where methane reacts with water to produce hydrogen gas and carbon dioxide gas, and if we calculate the number of moles of reactants and products, we can see that there are 4 moles of gaseous product and 2 moles of gaseous reactant. Therefore, entropy of the system increases. If we look at the second equation, we can see that the system changes from 4 moles of gaseous state to 2 moles of gaseous state. Therefore, entropy of the system decreases. What is standard entropy change? Standard entropy change is the absolute entropy of a substance at 100 kilopascal and 298 Kelvin, and it has symbol delta S theta. If we have the reaction like this, the standard entropy change of the reaction equals sum of standard entropy changes of the products minus sum of entropy changes of the reactants. By doing this, we can calculate overall standard entropy change of the reaction and predict whether the entropy increases or decreases. Let's consider the following chemical equations and determine which would have the most positive value of delta S. Let's consider each of them and choose which reaction has positive value of delta S. Let's look at the reaction A. The change in moles of gaseous state from 3 to 3. Therefore, there is no change in entropy. B, from 4 to 2. Therefore, entropy decreases. C, all reactants and the product are in solid state. There is no entropy change. D, 2 moles of reactants to 4 moles of products. Therefore, entropy has the positive value. After looking at entropy, we are going to focus on the second law of thermodynamics. Based on the second law, entropy of the universe increases in a spontaneous process and remains unchanged in an equilibrium process. If we speak mathematically, if we have increasing of entropy of the universe, we will have spontaneous process. But at equilibrium, entropy of the universe equals 0. What is the system and what is the surroundings? The system is where the chemical reaction takes place. For example, reactants, products, or any solvents. Surroundings, it is measuring apparatus, thermometer, for example, other devices, sensors, everything external to the reacting substances. Entropy changes refers to enthalpy of the system. They are closely related to each other. And due to close relationship between delta S and delta H, we are going to include a new concept which is called Gibbs free energy. Gibbs free energy change is an indication of whether the forward or reverse reaction is favored. The mathematical relationship between Gibbs free energy, enthalpy, and entropy is delta G equals delta H minus T delta S. The Gibbs free energy expressed in terms of enthalpy and entropy and can be used to predict the spontaneity of the reaction. If we want to predict the spontaneity of the reaction, we are going to look at negative value of delta G. What is spontaneity? So we discussed with you the spontaneity of the process, but spontaneity of the process will give us information only about feasibility of the reaction, but not with its rate. So many reactions can be spontaneous but slow. Some of the reactions can be very fast but non-spontaneous. For example, the combustion of graphite is spontaneous at all temperatures, but graphite is virtually completely stable in air at room temperature. This is because the reaction has very high activation energy. We will look at the example where we are going to practice in calculation delta G of the reaction. For example, is the decomposition of calcium carbonate spontaneous at 298 Kelvin? So look at the reaction. So look at the values. For example, delta H has positive value, delta S has positive value. Therefore, this reaction is endothermic with increasing the entropy value. How to calculate delta G? We will use mathematical equation delta G equals delta H minus T delta S. And simply you can put all the values and calculate delta G and use the temperature 298 Kelvin. What are the methods of calculation of delta G? The first method, using the equation delta G equals delta H minus T delta S. And the second, using equation of free energy of formation. So by using this equation, you simply subtract sum of Gibbs free energy changes of products minus sum of Gibbs free energy of reactants. How to use the second method? You will apply thermodynamic data from the booklet. You will find data for delta H of formation, delta G of formation, and S entropy values from this table, and you simply put all the values in the equation and predict the spontaneity of the reaction. Prediction the effect of a change in the temperature of the spontaneity of a reaction using standard entropy, and enthalpy changes in the equation delta G equals delta H minus T delta F. So for example, which factors affecting Gibbs free energy and the spontaneity? We looked at different factors. For example, temperature can affect the spontaneity of the reaction, and also it depends on whether the reaction is endothermic or exothermic, and also it depends on entropy values, whether it's positive or negative. The first condition, for example, if we have exothermic process where disorder increases, it means that delta H of the reaction is negative and delta S of the reaction is positive. Delta G of such reaction is always negative, always spontaneous at all temperatures, because the value of T delta S is negative at all temperatures, because delta S is positive and delta H is negative. So the value T delta S will be always negative. Second condition, where we have exothermic reaction, where disorder decreases. It means that we have delta H negative, delta S negative, and therefore delta G will be negative at low temperatures and positive at high temperatures. For example, if we have low temperature value, T delta S value will be negative, and overall delta G will be negative. But if we have high temperature value, it means that T delta S value will be overweight delta H value, and therefore delta G will be positive. Third condition, where endothermic reaction and we have disorder increasing, it means that delta H value is more than 0, delta S value more than 0, delta G will be negative at high temperatures and positive at low temperatures. And the fourth condition, where we have endothermic reaction, where disorder decreases, it means that delta H of the reaction has positive value, entropy change has negative value, delta G is always positive, never spontaneous, because as delta H is positive, T delta S value will be positive also, because delta S is lower than 0, never spontaneous. What is the relationship between Gibbs free energy and equilibrium? If we have more negative value of delta G, the more forward the reaction is favored and the larger value of equilibrium constant. If we have the system which is at equilibrium, so we will have maximum value of entropy and minimum value of Gibbs free energy. Why? Because when the system is at equilibrium, we will have mixture of reactants and products with constant concentrations. As we remember, mixture will have higher entropy value, and position of equilibrium corresponds to minimum of value of Gibbs free energy. Gibbs free energy helps us to indicate whether the forward or reverse reaction is favored. How to indicate it? If delta G is negative, it means that the forward reaction is spontaneous. Kc has large value. If delta G equals 0, it means that the reaction is at equilibrium. But if we have positive value of Gibbs free energy, it means that the forward reaction is non-spontaneous and backward reaction is favored. We can use the relationship between delta G and temperature to describe the relationship between equilibrium constant and Gibbs free energy. Delta G equals minus RT logarithm K. So we can calculate equilibrium constant by rearranging this mathematical relationship, and we can find equilibrium constant value. What is the relationship between equilibrium constant value and Gibbs free energy? If equilibrium constant equals 1, delta G equals 0. The system is at equilibrium. If equilibrium constant more than 1, so the delta G of the reaction is lower than 0, has negative value. It means that equilibrium shifts to the product side, product favored reaction. If K less than 1, delta G has positive value. So the reaction is reactants favored. Equilibrium shifts to the reactant side. And next we are going to look at several examples where I will show how to calculate equilibrium constant using the previous relationship between delta G and equilibrium constant. How to calculate delta G of the given chemical reaction of oxidation of iron. Given enthalpy value, change in enthalpy, change in entropy, and temperature. So we will use the relationship between delta G, delta H minus T delta S. And then simply put all values in this relationship and find out delta G value. Delta G of this reaction equals minus 824 kilojoule per mole, minus temperature is 300 Kelvin, multiplied by delta S, minus 270.5 joule Kelvin minus 1 mole minus 1. Here the value, the unit is in joules, therefore we need to convert it in kilojoules. Divide by 1000, minus 270.5 over 1000, joule Kelvin minus 1 mole minus 1. Then these two minuses will give us plus. If this value will overweight this value, it means that the reaction is spontaneous. But if this value will be lower than this value, it means that the reaction is non-spontaneous. Do you remember the previous explanation about the relationship between temperature and delta G of the reaction? So it means that firstly, let's calculate it, and then we will continue. The final answer is minus. It means that delta G is negative. The spontaneous process will take place. We have negative value of enthalpy, therefore the reaction is ectothermic, and negative value of entropy, therefore the disordering of system will increase. It means that the reaction will be spontaneous only at lower temperatures. If we have higher temperature, the positive value of this T delta S will overweight negative value of delta H, and the reaction will become non-spontaneous at higher temperature. The reaction is spontaneous only at low temperature. We can predict the spontaneity of a chemical reaction using standard electrode potentials. The standard electrode potential can be used to predict whether the redox reaction is spontaneous or not. Spontaneous redox reactions always occur between the strongest oxidizing agent and the strongest reducing agent in two half equations. The products of the redox are the weaker reducing and oxidizing agents. For example, can acidified aqueous solution of potassium dichromate spontaneously oxidize a solution of bromide ions to bromine? How to predict whether this reaction is spontaneous or not? Firstly, we should look at half equations when potassium dichromate turns into chromium 3 plus ions, and when bromide ions turns into bromine molecules. We will look at cell values, standard electrode potential values, and then we will predict the spontaneity of the reaction. If standard electrode potentials, when we add them to each other of two half equations, has positive value, it means that the reaction is spontaneous. Second example, will acidified potassium dichromate oxidize iron 2 ions? Again, we need to look at values of standard electrode potentials of two half equations. First half equation, where dichromate ions turn into chromium 3 plus ions, and when iron turns into iron 2 plus ions. When we add two standard electrode potentials, and when the overall cell potential will have positive value, it means that the reaction is spontaneous. Using standard electrode potentials enables the spontaneity of a reaction to be determined. But remember that it gives no information about the rate of the reaction. So even though it is spontaneous, the reaction may proceed very slowly. How to use standard cell potentials and Gibbs free energy to predict the spontaneity of the reaction? We will use the next relationship between Gibbs free energy and cell potential. N is the number of electrons transferred in a redox reaction. F, the constant value, it is Faraday's constant. And E, cell potential will be calculated from the standard electrode potentials of two half equations. The relationship between the cell potential and Gibbs free energy. If we have positive value of cell potential, the delta G of the reaction will have negative value. Therefore, the reaction will be spontaneous. If we have negative value of cell potential, delta G will be positive and the reaction is non-spontaneous. If both values are 0, it means that the reaction is at equilibrium. So let's practice by using the next practice questions. Work out the cell potential and delta G for each of the following and predict whether the reaction will be spontaneous or not. So firstly, we will look at the reaction between zinc and aqueous silver ions. So first we need to calculate the cell potential. So the cell potential of this reaction has positive value, and therefore delta G is negative. how many electrons are transferred in the reaction? 2 electrons, because zinc will lose 2 electrons and 2 silver ions will gain 1 each of electrons. So the overall 2 electrons are transferred. You will put the values in the previous mathematical relationship between delta G and cell potential and calculate delta G of the reaction. For the second and third reaction, you will do similar steps, and also you will look at the number of electrons that are transferred between 2 half equations. We discussed with you all the main points that we highlighted in the learning objectives. Now you know how to predict whether the reaction has high entropy value or low. You know how to use delta S value to calculate the entropy of the reaction. You know how to use the relationship between delta G, delta H, and delta S. And you know how to calculate using mathematical relationship between Gibbs free energy, enthalpy, and entropy. Also, we explored how to use the standard electrode potentials to calculate delta G and to predict the spontaneity of redox reactions. Hopefully, we achieved all our learning objectives. Thank you for your attention. Good luck.